Wasn't even able to finish that one. So sad. In my personal opinion, yes. But I don't want to put words in your mouth. So lesson 5. Stuff for today is going to be rhombi and square. So rhombi means a rhombus, more than one. So anyway, that's the stuff we're doing today. We're dealing with rhombuses, rhombi, and squares.
Oh, this is 6.
Yeah. So this lesson, the normal part of the lesson, deals a lot more with proofs. Because of that, we're going to skip over a lot of that stuff. So this lesson is going to be, like the notes on here, will be a lot shorter. And then also the lesson itself, or the homework itself, will be shorter as well because we're skipping over all those proofs. Okay. All right, first and foremost, a rhombus, what is it? A rhombus is a 4-sided figure with every single side being the exact same length.
Oh, yeah.
Okay? So every single side has a side that's the exact same length. Think like a square that somebody squished. Okay, it's kind of fell over and kind of got skewed a little bit. That's what a rhombus is. Okay? So it has all 4 sides that are the same length, and the only thing that's different is that the angles are not going to be like perfectly square like a square is. So with a square, what do you know about squares? Okay, so in a square, again, not a great picture, but you get the idea. Okay, all sides are equal. Perfect. All sides are equal, and all angles, I'm going to put a little angle sign like that, are 90 degrees. So a square, all sides are equal, all the angles are 90 degrees. In a rhombus, only that it is, it's just all sides are going to be equal. If all the sides are equal, it also makes it a parallelogram, which is why it fits into the chapter called parallelograms. Okay. So here's the other little parts of the notes. I will kind of draw a picture for you to explain this stuff. But really, there's 2 parts that I want you to get out of this, and that's why I'll draw a rhombus, and I'll color it better than what all those words are. Okay? So bear with me as I make that shape again. Try that again. Okay, so I've got a rhombus. Sure, we'll call that. Yeah, it's rhombus enough. I know it's not great, but you get the idea. Okay, with a rhombus, when you have a rhombus, even though all the outsides are the same length, the center part is going to be a perfect 90-degree angle. Okay, this works with both squares and with rhombi, but the bisectors, the ones that cut through the diagonals of it, they will all be perfect squares. So meaning it will all be 90 degrees. The other rule that goes along with the rhombus, and this is what all those numbers in that picture on the side are trying to say, is that this angle, this angle, this angle, and this angle are all the exact same angle, or exact same degrees. Okay, all of those are the same set of degrees, and all of these ones, that angle, that angle, that angle, and that angle, are the exact same degrees. That's what these two theorems over here were telling us. Middle bisectors, 90 degrees. These opposite set of angles are going to be the same. These opposite sets will be the same. Questions on that? Anybody need more time? Good? Okay. So I'm going to jump down to here. Oh, I didn't erase all of it. My bad. Oops. Okay, so we've got this rhombus over here. Again, there's a lot of proof stuff that's going to happen later on. This is the most important stuff that's going to happen. It's really is. It's freaking out right now. However, it's not showing up on this screen. That's freaking out. Okay, better, I think, right? All right, so for this one, it says the diagonals of the rhombus intersect at point B. Okay, so that tells me that they're cutting across here. 90 degree, 90 degree, 90 degree, 90 degree. It says that angle WZ, X. I gave the wrong color. Let me grab a pen. So this angle right over here was 39.5 degrees. It tells me that angle ZYX, so Z, Y, and X, so this whole entire thing is what I want to find. So the stuff that we know, I know if this angle is 39.5, that this angle is 39.5, this one's 39.5, and that one's 39.5. I'll zoom in a little better so you can see it. Ellie, say it again. It's a triangle. Ellie saw it right away. This is a big old triangle. I've got this one, I've got this one, I've got this one. In that triangle, I know two of the sides. I only need to find out one more. What do all triangles add up to? 180. Perfect. Ellie, you caught it. If you're up for it, you want to tell me how I can solve it then? So 39.5 times 2, because there's two of them, two of those angles. I'm going to say plus X, or I'll put plus a question mark because I don't know what that one is. And what's it going to equal? 180. Fantastic. What's that? I will draw it. Oh, this will highlight it. So they want to find this angle Y. So from here to here to here, that's the triangle. So I've got this big part here, which is going to be the triangle. So I've got this, I've got this. I just need to know that big part over there. So you told me to do 39.5 times 2. I'm going to put these in parentheses just so we can kind of see it. 39.5 times 2 equals 79. Plus, I didn't give it a variable. I'm just going to give it a question mark, or I could say angle Y equals 180 minus 79 to both sides because it's just algebra at this point. That tells me my missing angle, angle Y, equals 101 degrees. So find angle ZYX, 101 degrees. Okay, I'm going to redraw this shape again because this one I don't want to get too crazy, especially since I'm going to post these notes. So let me draw this new shape again. Scroll down to there. my shape looked like this-ish. Not great, because I don't have one of those fancy ones that lets me do things. All right, I'm going to draw some lines going straight across it. That one goes there. This one goes there. My letters were, I'll say Z, W, X, Y, and V. Again, I'm using this just because that's the only shape I can make that looks a little bit prettier. It says WX is 8X minus 5. And then it says WZ. Yeah. WZ is 6X plus 3. What do you know about the sides of a rhombus? They're all equal. So what can I do to solve for X? Perfect. Set them equal to each other. So I got 6X plus 3 equals 8X minus 5. Okay, I'm going to subtract that 6X to both sides, minus 6X. So I get 2X over here minus 5 equals 3 plus 5 plus, or sorry, that was plus 3. So plus 5 to both sides. I get 8 equals 2X. Divide them both by 2. Tells me that X is going to equal 4. So when this said just find X, we set them equal to each other. We solved it. X equals 4. Thumbs up, thumbs down. What are you guys feeling? So good. Love to see it. All right, this is the one that people got frustrated at me on for the last one, so I apologize in advance. This one, I got this shape here. It says FK equals 5, FG equals 13, find KJ. So we got that shape. I'll let you draw it if you want to do that first, and then I'll get going. Okay, I'm going to grab another pen. I'm not going on yet. Just letting you know why it looks different for a second. Okay, if I plug this information that I have in here, it said that FK, the length of this line here, was 5. It told me that FG was 13, and it wants me to find KJ. No. It would be if it's a square, but it's not a square. So I know that these two are the same length, and these two are the same length. 13's on the outside. So I don't know this one yet, but I can figure it out. Because I know that this side's 13, I know this one's 13, this one's 13, this one's 5, and this one's 5. The inside of a rhombus, the bisectors, or the diagonals that cut through, how many degrees are these? 90. If I know that the center is 90 degrees, and I look at that shape that we already had, FG, the hypotenuse, is 13. Okay, this side over here was 5. And based on that picture, the thing that we don't know is going to be the bottom edge of this. So I do kind of like this shape here. I have this one, I have the hypotenuse, I have this one. So I don't know what this one is over here, this KJ. If I knew a triangle like that, could I solve it? Remember what it's called? Pythagorean's theorem. Perfect. I can set it up and solve a problem that looks like this using Pythagorean's theorem. So I could do a squared plus b squared equals c squared. So that would be 5 squared plus b squared equals 13 squared. 5 squared is 25. Plus b squared, still don't know what it is, equals 13 squared is 169. 9 minus 25 to both sides. B squared equals 144. To get b all by itself, slide over. I'm going to do the square root. So 144. I'm going to do the square root of that. God bless you. That tells me that b is going to equal 12. So the length of kj, because we did all that, this one here, will equal 12. Okay, and again, that's why we spent so much time dealing with triangles. As soon as we got triangles mastered, pretty much all the other shapes that we'll deal with later on can kind of get broken down into a whole bunch of triangles, and we can solve that stuff pretty quick. Okay, same thing, I'm going to do this one again. I'm going to draw the shape one more time. I'm not going to use the fancy tool just because I can do a little bit quicker, even though it doesn't look as pretty like at all. Here's a G, here's an F, here's a J, here's an H, and there's a K right there. Okay, it said that angle JFK, so this one over here was 6y plus 7. It said that KFG, this angle right here, was 9y minus 5. What can you tell me about those angles? They're the same thing. Set angle, you got it. So I got 9y minus 5 equals 6y plus 7. Okay, I'm going to subtract the 6y. I'm going to add the 5. I'm going to do 2 steps at once. So subtract the 6y. That gives me a 3y. I'm going to add the 5. That's going to give me a 12. Got to do in those steps real quick together. Divide this side by 3. Divide this side by 3. Y equals 4. It's saying, what's the value of y? I don't need to go through and plug it back in, but if I wanted to figure out what the angle is, I could plug it back in. So good? So good. Don't worry about this. We already did this by drawing my picture. The thing I want you to see is this guy right here. So in a parallelogram, rhombi, they're going to have 4 sides that are all the same length. Rectangles have all 4 angles that are the exact same degree. With a square, squares are those special ones that have the exact same length and the exact same angles. Let's check and see what we're done. Yeah, so much time. 32, yeah. And we've got like one mini proof that we're going to do, and I'm going to explain that one. It's not scary, I promise you. Okay, I got one mini kind of proof using this picture up here, this parallelogram rule. And that's kind of where we're going to go with it. Hector. He is measuring the boundary of a new garden, making a garden. He wants every single side, or he wants the thing to be a square. So he set every single corner stake 6 feet apart. What sort of things would he need to do to make sure, to verify that this was a square? So if you were trying to figure out if it was a square, what are ways that you could prove or make sure that this is actually a square? What'd you say?
90 degrees.
Okay, so make sure every corner is 90 degrees. Delaney, what'd you say?
You have to make sure like all the sides are the same.
All sides the same, perfect. Okay, there's one more thing. This kind of goes along with what we did with rectangles.
Make sure it like adds up to like 360 or whatever.
Well, that'd be, well, if you had that corner, no matter what, if they were 90 degrees, they'd add up.
Something with like the inside of it. Make sure that
Yes. Yeah, the diagonals. I was thinking that unless you're talking about. Anyway, so all the diagonals, if the diagonals are the exact same length. Okay, if the diagonals are the same length, then that proves, if the diagonals are the same length, that'll prove that every one of these corners is going to be 90 degrees. For this, again, I can't spell, I'm letting you know right now. For this part, if you can do any two of these, if you can do any two of those, you'll prove it's a square. So if you show up, like I'm just going to say real world, if you are a contractor and you don't have a protractor when you show up to a job site, you can measure all the sides to make sure they're all 6 feet exactly. And then you can do the diagonal with the tape measure across to make sure it's square. Perfect. Okay. If you do have a protractor, you can show up, make sure every corner is 90 degrees, and make sure that you have all the exact same sides, the same length, all 6 feet. Perfect. If you did the diagonals being the exact same side or same length, and you make sure that all your sides are the same length, that's another way to make sure it's a square. Or sorry, yeah. Anyway, that's exactly what you're going to do for that stuff. Okay, all the sides the same, and then make sure your diagonals are going to be the same. That's the proof stuff. I'm not going to get into this because we're not going to do that, nor am I going to make you guys plot some points today. Okay? Homework for today. Kind of a shorter one. 8 through 12 even. 24 through 30 even. And then 31 through 33 all. You guys have like just short of 20 minutes? Have at it.